You know, humanity is always on the hunt for the critical stuff that powers our world. And right now, that search is taking us to two of the most wild, most extreme places you can possibly imagine: the crushing, dark depths of our oceans and the total vacuum of space.
So that brings us to the big question, right? It sounds simple, but the answer changes everything. To build our future, where do we place our bets? Do we look down into the deepest parts of our own world, or do we look up to the stars?
So think of this as a tale of two massive frontiers, two totally different quests for the exact same treasure. On one hand, you've got the deep ocean. It's mysterious, it's right here, but it's incredibly hard to get to. And on the other hand, you've got the asteroids, floating out there with just an unbelievable amount of promise.
All right, let's start by looking down. The deep sea, no question, holds incredible wealth. But as we're about to see, getting to it presents a huge dilemma, and it comes at a very, very steep price.
So what are we even talking about here? Okay, picture this. Thousands and thousands of meters underwater, the ocean floor is just scattered with these rocks. They're about the size of a potato, and they're called nodules. But the thing is, they are packed with cobalt, nickel, copper, all the stuff we absolutely need for electric car batteries for our smartphones. It's like a giant treasure chest sitting in the dark. The tech they're using is pretty wild, but you can actually get your head around it with some simple analogies. They've got these subsea crawlers, which are basically giant underwater bulldozers. Then there are AUVs, autonomous underwater vehicles, which act like Roombas, just mapping the seafloor. It's all incredibly sophisticated, remote-controlled machinery that has to work in a place that's just impossible for humans.
But, and this is a huge but, there's a massive catch. Those underwater bulldozers, they create enormous problems. I mean, they completely destroy habitats that have been developing for millions of years. They kick up these giant clouds of dust, they call them sediment plumes, that can choke out marine life for miles. Not to mention all the noise and light pollution in a world that's supposed to be dark and quiet.
And here's the bottom line. The most important thing to remember: the deep sea is not some empty warehouse we can just go into and take stuff from. It is a living, breathing, and unbelievably delicate ecosystem. And this quote just says it all. Mining down there carries a real chance of causing irreversible harm. That means damage that you can never, ever fix.
Okay, so this is where the story takes a really fascinating turn. Because all the tough lessons we're learning and all the incredible tech being built for the ocean, well, it turns out it might actually have a much better home. All that work is building a bridge, not across an ocean, but straight to the stars.
And here's the brilliant part, the good news. Almost every single robot, every sensor, every arm they've designed to withstand the crushing pressure of the deep sea, it has a twin that can work in the microgravity of space. But when you make that leap, the technology doesn't just work, it gets better. It gets simpler, way more efficient, and so much cleaner.
Look at the underwater crawler, for example. It's got to be super heavy, super powerful to deal with all that pressure and gravity. Now look at its cousin in space, an asteroid rover. The basic idea is the same, remote operation. But in almost zero gravity, the whole machine can be lighter, nimbler, and needs way, way less energy to do its job.
And this comparison is even better. Down in the ocean, you'd use a suction pipe. It's a messy, brute force kind of tool. But in space, you can use something called optical mining. This is just beautiful. It uses concentrated sunlight, like a giant magnifying glass, to heat up the rock and break off the resources gently. No physical contact, no dust clouds, no collateral damage. It's a completely clean process.
Which brings us right to the heart of this whole thing. When you really stack them up against each other, asteroid mining stops looking like some far-off science fiction and starts looking like the clean, smart, and frankly, the obvious choice for our future.
And let's just start with the single most powerful argument there is: zero. That is the number of living ecosystems you damage when you mine a dead rock floating in the vacuum of space. You get the resources we need, and you leave Earth's incredible oceans completely alone.
And the environmental payoff is just staggering. Look at this chart. To get 1 kilogram of platinum on Earth, you could generate over 20,000 kilograms of CO2. From an asteroid, early estimates say that number could be as low as 150 kilograms. That's not just a little better, that's a reduction of over 99%. It's a total game changer for getting resources sustainably. And the benefits just keep stacking up. We can use the resources right there in space. That's what in situ resource utilization means. You could turn water ice into rocket fuel. This opens up a supply that is, for all practical purposes, infinite.
A single asteroid could have more precious metals than we've ever mined in all of human history. And every step we take builds the infrastructure we need to really become a multiplanetary species.
So let's just zoom out for a second and look at the grand vision here. This isn't just about grabbing materials to bring back to Earth. This is about building a brand new, sustainable economy in space itself, an economy that can benefit every single one of us.
And you know, this isn't just a fantasy. There's a practical roadmap to get us there. We start close to home, in our own cosmic neighborhood, the moon and the asteroids that fly close to Earth. Once we prove the tech and build the systems there, we expand our reach out to the main asteroid belt, going after massive metal-rich targets like Ceres and Psyche. It's a logical, step-by-step push out into the solar system. Just imagine it for a second. The year is 2035, just over a decade away. Swarms of little robots are gently carving up an icy asteroid, turning that ice into rocket fuel for a gas station in space. This makes missions to Mars cheap and routine, and all of it happens with zero damage to our homeworld. No ocean plumes, no lost habitats, just clean, optimistic progress.
So in the end, the technology that was born from our desire to mine the deep ocean has been an incredible teacher, but it feels like its real destiny, its true home, is in space. Because when we finally have the choice, when we can look up instead of down, the treasures we'll find and the clean, abundant future we can build with them are truly endless.